Now let's talk about Charles law. Charles law is explained by Jacques Charles. As he observed, I mean, as he observed that, as and explained that that when you have a constant pressure with a relationship with its volume, and then it is a explanation of volume and temperature. So according to him, if you have having higher volume of gas, it is directly proportional to its absolute temperature. So that means if you have higher volume, you should will be having higher temperature. If you're having higher temperature, you'll be having higher volume. Same thing, like for example, have an experiment of you have a certain balloon with a um, and you put it in hot water, then for sure your balloon will expand. So that is his explanation. So if you have higher temperature, according to him, you'll be having higher volume. Okay, if you have lower temperature, you'll be having lower volume. That is, it is directly proportional. Okay, so let's move. Okay, according to Jacques Charles, the equations that you can use for this, you can use volume 1 over temperature 1 is equals to volume 2 over temperature 2, or you can use this formula, volume 1 multiplied by the temperature 2 is equals to volume 2 multiplied by the temperature 1. Okay, they are just the same thing. Okay, let's try to know this. Like for example, you need to get the volume 2. So you put some temperature to both sides. Here, both side, temperature 2. So you can cancel out this one. You'll be having volume 2 is equals to volume 1. So this one is temperature 2 man. So you can multiply them. This is a multiplication. So you can just put directly here the temperature 2 if you want, because it's a multiplication. So volume 1 times the temperature 2 over temperature 1. Okay, let's prove that they are the same. So in this case, you are going to, if what is beside the volume 2 that you are looking for, so you need to divide them both sides. Let's okay, then both sides besides of the volume 2, which is temperature 1, like temperature 1 and temperature 1, this one will be cancelled out, right? So we'll be having volume 2 is equals to volume 1 times temperature 2. Look, volume 1 times temperature 2 divided temperature 1. So they are just the same. Okay? Okay, this time let's try to solve something. In this case, take note that it's talking about temperature. You need to convert the degree Celsius to Kelvin temperature. So when talking about Kelvin temperature, you will just add 273 Kelvin to the degree Celsius so that it turns to Kelvin. That's it. Like for example, you have 30 degrees plus 273, you'll be having 303, right? Am I correct? Yes, 303 Kelvin. So that's it. So it turns to Kelvin. That's easy. Or if you need to go back to degrees Celsius temperature, you just deduct them. I mean, not deduct. The term is subtract them. Okay? I hope you understand. Okay, let's move. So, like for example, you have a given equations. If you have a given problem like this, 3 liters of hydrogen at negative. Okay, let's write here given. The given is, okay, first the given, then forget that. The okay, 3 liters of hydrogen. So 3 liters is volume. So look at it as volume 1. 3 liters of hydrogen with a negative degree Celsius, allowed to warm to 27 degrees Celsius. So the volume, the temperature one is negative 20 degrees Celsius. And then the volume, the temperature 2 is given also, which is warm to 27 degrees Celsius. And your volume 2 is being asked. So, look at the formula that we had derived earlier. You can use this. Volume 2 is equals to this one. Okay, you can write volume 2 is equals to volume 1, which what is your volume 1? 3 liters. And then multiply with a since it's temperature to this one, 27 degrees Celsius. So to turn this one into temperature, you just add 273. So 27 plus 273, you have 300 Kelvin. So use here 300 Kelvin. That's it. Then divide them with a negative 20. So you can write negative 20 plus 273, you have 553. So you have, 253 Kelvin. So the Kelvin will be cancelled out since it's division. You'll be having liters in this answer. So you need to write volume 2 is equals to um what? So you need, 3 times 300, 3 times 300, you got 900, divide 253, you got 3.55. What is the unit? You have liter. Then this is the volume 2, 3.55 or 3.56. You can round off. So 3.56 liters. That's the right answer. I hope you understand this. Okay, take note, like for example, you are asked to get the temperature. Okay, let's talk about this. I erase this one first. What if you are asked to get the temperature? Since, sure, it's very libog, yes, not libog. It is very easy. Sorry for that. It's you are confused. Sir, it's very confusing. No, it's not confusing. Talking about this, like what if you are asked to get the temperature to? You cannot put volume to here since it's multiplication. So you need to swap them. So this one, that temperature one, if you're looking for temperature two, the temperature one will be in the higher, then volume one will be in the lower. You can change that, and then temperature will be in the higher, and volume two will be in the lower, or in the denominator. Sorry for the term. So you put here volume 2 so that both sides, so that you can derive the formula. So you'll be having temperature 2 is equals to temperature 1 times volume 2 divide volume 1. That's it, the correct answer. So you just need to swap them. That's the easiest way. If you are if you are asked to get the temperature, okay? Or even though even in volume and pressure relationship, which is in Boyle's law, you can also swap them if you're looking for in the denominator area. Okay, I hope you understand. Okay, bye class.